One application of slope is the concept of average rate of change. In this case, the slope refers to the change in one quantity, y, per unit of change in another quantity, x. As you know, the slope formula is this one. Very common formula, though it's not used in everyday life. It's used a lot in math anyways. So this formula requires having 2 points in this form, x1, y1, and x2, y2. That just means that the two values coordinate with each other, right? That seems like it's a good word for it. For this project, compare the total population in your community in 2010 to the total population in your community in 2000. Suppose you live in Taylorsville, Utah. I suggest Googling that. And then this website, maybe, I don't really care if you use that website, by the way. Click on that link and the information for the next step would be given. Let's go ahead and choose a community to evaluate in this one. All right, Salt Lake City, Utah, the Y values for the two ordered pairs will be the populations from those years. So I'm going to go ahead and Google this, right? 2000, according to this Google, whatever it is, and who knows how accurate it is, but that's not the point. We're not into accuracy on this one, okay? Maybe we should be. But it says in Salt Lake, 2000, there was the population was 181,740. That still seems kind of low, but whatever. Here we go. By the way, a couple things we need to remember on this one is the x value for this, and I don't see that it's set on here, but it should. No, it did up there. No, it didn't. The x value is going to be the year, okay, and then the population is the y value. There is a reason for that, by the way. So y values are depending on x values, always dependent on. So you got to look at the two and make a determination that may take some analysis on your part to figure out which of the two is dependent. But definitely the population will depend on what year we're looking at, right? Like if you go to the year, I don't know, 500, then very low population, you know what I'm saying? Because it depends on the year. So this one says 181,740. So I'll see if I can write that in here. 181,740, and that was for the year 2000, right there. All right. All right. Next up, we'll move on to 2010, and this one is showing in 2010 the population was 186,571, and that was for the year 2010. That's a zero right there. All right. So this is all the information we would need to find the average rate of change in Salt Lake City population between these 10 years. Now, of course, does that mean it's always consistent? No, it does not. But it does give you the right, apparently, to make various statements about how numbers change. And people do this all the time, so you guys know the news lies a lot with this kind of information. So, well, let's figure this out, okay? So it says the average rate of change, so we got to figure out how much change actually occurred, right? Now, could we use that formula? We could. You know, I'll give you guys the choice. Let's do the formula, and you know, maybe you'll use the formula even in the homework, okay? Now that's set up. That's not a divide sign, by the way. That's our formula for this one, right? So it says y2 minus y1, and it doesn't matter which you choose to be the first point or the second point. For me, the purple one will be the second point because it's bigger. What I'm talking about is the population is bigger in 2010 than it was in 2000, which is not, it's going to eliminate any possibility of negatives for us, okay? Because we know it was in 10 years. So what was the population in 2010? And that would be the denominator part of that, the year. It was 186,571. 186,571. That's better. And what was the population in 2000? Oh, well, what I have written there, 181,740, right? I'll make that 4 a little better. Well, I don't know if that was much better, but it's better. All right, well, how do we solve this? Well, oh man. All right. Well, you can actually put this into a calculator like this. You can type it in exactly like you see it. Like if you guys have this Casio like I have, it's got the fraction button right there. You push it and then it gives you an actual fraction. Then you type in this exactly like we see it. If you got the TIs or you know, well, not the phones. I don't know if the phones can do that. I'm such a nerd, I don't actually use my phone calculator. But in any case, not because I know it, just because I carry these ones with me. So we can type this in, but let's say that we didn't know that function was part of the calculator, right? So I'd do 186,571 minus, so we're actually finding the difference here. 181 minus 181, 740. And so that tells us how much the population changed, right, in Salt Lake City between the 10 years. 4,831 people. And since it's positive, we know that it's an increase in population there. And how many years did this take place? Well, 2010 minus 2000, that was 10 years of time change, I guess. Well, that doesn't really help us, because I am working informally on number 2. Calculate the slope of this. Run your answer to the nearest whole number. Okay. Well, if you divided this by 10, that's not a hard calculation. You just move the decimal one time to the left right there. And then you could see that would be 483.1 people per year. But it did say it rounded the nearest whole number, so I'm just going to change this to 483. And again, this would be people per year. And you can write this rate like this as well. Okay, so that's the average change that we would expect. Oh, I guess I could have kept that as 483, because the next question is going to say, well, what was the average annual rate of change in the community from 2000 to 2010? Well, it's the same answer. And this goes along the lines of just hoping to help you guys figure out that a rate of change actually is the slope. Oh, I gotta spell it right. Rate of change is slope. It's people per year. Now, if you wanted to go real deep into this and say it's adding 483 people per year, do it, all right? But I'm a lazy math guy, so I'm not going to do it. That's fine as a rate of change and as a slope. And again, as a slope, if you just put the 483, that's fine, okay? Now, of course, this brings up other questions. Is it consistent every year? Probably not. Could we make assumptions about it in the future? I guess if you want to. Does that mean it's accurate? No. But people do this all the time, and they manipulate people's brains, which is unfortunate. Now, if you were to graph the line with this information, right, the slope, would it be positive or negative? Well, we know that it was adding people. That would be the first thing that you'd notice, which means it's positive. But also our value actually is positive, right? It's a positive 483, so this one is a positive slope.